everyone, welcome back. You know how we've all been kind of like obsessed with these long context language models lately?
Yeah,
Well, get this. We're going deep on a paper that could seriously shake things up, like how AI, crunches all that information, especially like those giant chunks of text.
like massive code bases or, huge documents.
Yeah, stuff that used to make AI just completely like oak.
It's true. And actually, what's super interesting is that this paper, it tackles a challenge that's kind of been like holding AI back.
Okay,
The sheer cost of processing those long sequences.
makes sense.
Traditional AI models, with all their fancy attention mechanisms, they really start to struggle when the text gets super long.
Right.
It's like trying to juggle 1,000 things at once. Your brain would just fry.
Yeah. And for AI, that means like everything just slows down to a crawl.
Totally.
So this paper, it's called Native Sparse Attention, Hardware Aligned and Natively Trainable Sparse Attention.
Yeah,
It's a mouthful, I know.
it is.
But the idea is pretty cool.
It is, yeah. They call it NSA for short.
NSA, okay.
And NSA, it's all about making AI way more efficient by, like, getting it to be picky about what it pays attention to.
Okay, so it's kind of like skimming a book, right? Instead of reading like every single word.
Exactly.
Okay, I get that, but haven't people already tried this whole sparse attention thing?
Oh, yeah, definitely. There have been others, but they haven't quite, hit the mark.
Like what's the problem?
Well, some of them, they struggle to actually deliver the speed they promise.
Right.
And then most of them, they're kind of like tacked on after the AI is already trained. Almost
Oh.
like an afterthought.
Okay, so it's like trying to teach someone to speed read after they've already like spent years reading every single word.
Exactly.
Yeah.
And that's where NSA is different, you see. It's designed to be natively trainable. So that sparsity thing, baked in from the beginning.
Okay.
And get this, it's built to work really well with the hardware that we have now, like those powerful GPUs.
Oh, so it's taking advantage of the good stuff.
Yeah, absolutely.
Okay, so it's fast, but is it actually accurate? Can you really just like throw away information and expect the AI to still like do a good job?
You're totally right to ask that. That's the key, right?
Yeah.
And that's why NSA uses this three-prong approach: token compression, token selection, and a sliding window.
Okay, break it down for me.
All right, so token compression,
Yeah.
think about it like summarizing, a whole paragraph into one sentence.
Okay.
You get the main idea without getting bogged down.
Right.
And NSA kind of does a similar thing. It groups these chunks of information together and compresses them.
Okay.
Saves a lot of power.
So it is kind of like speed reading, but for AI.
Yeah, you could say that.
But hold on, wouldn't you lose some important details if you're only looking at those like compressed summaries?
Absolutely, you're right. And that's where token selection comes in.
Okay.
This is where NSA gets smart, you see. It identifies and holds on to the most important bits of information so nothing crucial gets lost.
Gotcha. So it's like finding that balance between like speed and actually remembering what matters.
Exactly.
And what about the sliding window? That's got to be important, right?
The sliding window, oh yeah, that's like a spotlight. It focuses on the most recent information, so the AI picks up those crucial local details.
Oh, okay.
Like, imagine it prevents the AI from getting too caught up in the big picture and missing something right in front of it.
Right.
So yeah,
Okay, so we've got this system, right? It's super efficient, balances compression and detail, but like, how does it actually perform in the real world? Does it live up to all the hype?
this is where it gets really exciting.
Okay.
The researchers, they put NSA through its paces, tested it on all sorts of tasks,
Yeah.
including some seriously tough ones with those super long chunks of text we talked about.
Right.
And the results, well, let's just say NSA kind of blew the competition away.
Ah, get out. So even though it's being picky about what it looks at, it's actually getting better results.
Exactly. It's not just about speed, it's about accuracy, too. NSA was on par with, sometimes even better than those traditional models.
Wow.
And it was way faster, like we're talking up to 9 times faster during training.
Okay.
Over 11 times faster when it's actually generating output.
That's wild. Okay, I remember this needle-in-a-haystack test from the paper. What was that all about?
Oh yeah, that's a perfect example of what MSA can do.
Okay.
Imagine trying to find one tiny bit of info buried in like a whole novel.
Yeah.
That's the needle in a haystack test. Can a model actually pinpoint that crucial info in a sea of text?
Sounds pretty tough. So how did NSA do?
Aced it.
No way.
Perfect accuracy across the entire 64,000 token context.
So it found the needle every time.
Every single time. Didn't get lost at all. Really shows how NSA can balance that broad understanding with laser focus.
That's seriously impressive. Okay, so we got speed, we got accuracy, but what about, like, understanding? Can we actually see how NSA is processing this info? The paper mentioned visualizing attention, right?
Oh yeah, definitely.
Okay.
Visualizing attention is like getting a peek inside the AI's brain.
Oh, cool.
You see which parts of the input it's focusing on.
Okay.
And with NSA, these visualizations, they showed this really interesting pattern. The attention scores, they kind of clumped together in blocks.
Oh, interesting. So instead of being like evenly spread out, the attention was focused on specific areas?
Exactly.
What does that tell us?
Well, it kind of backs up NSA's whole approach,
Right.
right? Focusing on blocks of info instead of each word or token individually.
Okay.
This clustering, it suggests that tokens within the same block, they're often related.
Right.
So it's more efficient to process them together. It's kind of like how our brains group words into phrases and sentences to make sense of things.
Yeah. Yeah, that makes sense. Like NSA is mimicking how humans think. Okay, so we've covered a lot. Speed, accuracy, even getting a glimpse of how NSA thinks. But let's take a step back for a second. Why should all this even matter to, the average person? How does NSA actually change things in the real world? So we've got this like super-powered AI, right? It can just blaze through information, but how does that actually change things for us regular folks?
Well, this is where it is really interesting. Remember that bottleneck we talked about earlier? The one that's been holding AI back from truly understanding all that, complex and nuanced information.
Yeah.
NSA just smashes right through it.
So it's not just about speed, it's about opening up like a whole new world of possibilities.
Exactly. Imagine AI assistants that can actually, follow a long conversation,
Yeah.
remember details from hours ago, or think about analyzing these massive data sets,
Oh.
medical records, scientific papers, all that stuff, finding insights that would take humans, like, forever.
Yeah, it's like AI can suddenly tackle all these problems that just seemed impossible before.
Right. And it goes even further than just making what we have now better. What about AI tutors
Okay.
that can actually personalize your learning based on everything you've ever studied? Not just the last few lessons,
That's crazy.
or AI tools that can help us tackle climate change by analyzing those huge climate models and spotting those patterns that we might miss.
This is blowing my mind. It really sounds like NSA could be the start of like a whole new era for AI.
It could be.
But I'm sure there are still some, challenges, right? What are those researchers still working on?
Well, one thing they're exploring is different ways to choose those key pieces of information, those tokens, remember.
Right.
NSA has to be super smart about what it focuses on.
Yeah.
Finding that balance between efficiency and detail, that's crucial.
Right, because if you compress too much, you lose the important stuff, but too little and everything slows down again. What else are they looking at?
Well, right now, NSA is a rock star at language processing,
Right.
right?
Right.
But could these same ideas work for other types of data, like images, sounds? Could we see a whole wave of sparse algorithms changing the game in other areas they are?
Now that's a thought. It feels like we're just scratching the surface of what's possible with this kind of approach. And I really liked how in the paper they actually talked about those other methods they tried, like the clustering-based approaches and why they didn't work out. It really gives you an appreciation for all the work that goes into these, breakthroughs.
Yeah, definitely. Shows that innovation often comes from trying new things, even if they don't work the first time.
This has been an awesome deep dive. NSA is seriously groundbreaking, and I'm super excited to see where it goes next.
It's been fun. And remember, the best part about learning is using that knowledge to, create something new. So keep exploring these ideas, see what piques your interest. Who knows, maybe you'll be the one making the next big AI breakthrough.
Couldn't have said it better myself. So until next time, keep that curiosity burning and keep diving deep into the world of knowledge.